Hey, welcome back. If you watched my last few videos, you've seen me do a lot of this. I'm hand cranking the table on my milling machine. More expensive machines often have a power feed built into the machine that can move the table at different speeds, which is much more convenient and can also give you cleaner cuts. And today that's what I want to add to this machine. You can buy complete power feed kits that you can retrofit to a machine like this, but they're kind of big and clunky, and I think they're too expensive, so that's why I decided to make my own. The hand wheel on this machine is fixed on the right side of the table, so the power feed will go on the left. I didn't really plan this project beforehand, so for starters let's just disassemble a few things to see what we're working with here. Turns out on this table it's a really simple construction. There's no bearings or anything. The end of the spindle simply runs in this bushing, and it already has a slot at the end, which I'm assuming can engage with the power feed that you can buy as an accessory for this mill. So I think I'm just gonna use that slot to drive the spindle, and here's some of the parts I'm going to use. This is a 24 volt DC motor which will drive the spindle. I bought this on eBay for about 40 euros and it has a worm gear attached to it, so this outputs a good amount of torque at low RPM, which is what we want for this purpose. To control the speed, I'm going to use this PWM controller, which I also bought on eBay for about 20 bucks. It's pretty simple. You just connect the motor and a matching power supply, and then there's a potentiometer to control the speed. And it also comes with a display that shows you the speed in percent and a forward and reverse switch. But do keep in mind these things only work with DC motors. And to power the whole thing, I just bought this 24 volt DC power supply, and I think this cost around 12 bucks. So overall I spent less than 100 on these main parts. The first step is to figure out how to attach this thing to the machine and have it drive the spindle, and I also need to come up with some kind of clutch mechanism to engage and disengage the motor from the spindle for when I want to use the hand wheel. I've seen a few solutions for this on YouTube, but I thought most of them were more complicated than they need to be, so I decided on a pretty simple solution, and here's a little breakdown on what my plan is. First, I'm going to make a little adapter that goes into the slot in the spindle and basically converts that to a hex drive, which is better suited for a clutch because it can engage every 60 degrees instead of only 2 positions. That will be held in place by a second bushing that goes on the outside. Then there's these 2 sleeves that screw directly into the base plate. Then the motor gets an adapter that can engage with the hex drive, as well as a base plate where these 2 pins can attach. And then the clutch will work by simply having the entire motor assembly slide on or off the hex drive while being guided by those pins. So it's a pretty simple construction, and hopefully it will be easy to build and reliable. First I'm facing the outside of that plate because it's painted, and I need a clean flat mating surface for the parts that will be installed onto this. This thing is made of cast iron, so that's why the chips kind of look like dust. Now I'm drilling and tapping some holes to install the new parts. First part is the additional bushing, which will consist of an aluminum ring for the housing and the bushing itself. There's a nice teachable moment here, because you should always stick something inside the bore when you cut off parts like this. They have a lot of momentum from spinning, and if you don't catch them somehow, then this happens. This was a fairly small part, so nothing happened, but it's still bad practice, so don't try this at home. Always try to catch your cutoffs. Now I'm making the bushing and I'm using some POM for that. Bronze or brass would be nicer, but that stuff is super expensive, and POM is actually not a bad material for bushings, at least for stuff that doesn't spin very fast. And also it's really easy to machine. You would think I would learn from my own mistakes, but honestly I just have no excuse for this one. So that's where that goes, and now I'm going to make the hex adapter that will sit in between these parts. I'm using some C45 steel for this, since I want something a bit tougher so it doesn't wear out too quick from the clutch going in and out. To machine the hex shape on there, I'm using a collet block, which makes this job really easy. You just put a part in the collet, and thanks to the hex shaped body, you just need to put it in the vise and rotate it 6 times to replicate the same shape on your part. The same thing can be done with a dividing head, but this method is even more convenient. Now this side of the part is finished, and it now fits into a 14mm socket, and that's the same socket I'm actually going to use to make the adapter that goes onto the motor. Now it just needs the flat shape on the other side, and I'm using a collet block again, but this time it's a 4-sided one. Now that it's finished, it can slide into the slot in the table spindle, and thanks to that shoulder it's being held captive in between the 2 bushings. Next I'm going to make the counterpart for that, which goes on the motor, and unfortunately I lost a bit of footage here, but all I did was to weld a socket from an old set to a piece of round stock, and now I'm drilling the hole for the motor shaft and cleaning it up a bit. Now I need to put a keyway into that hole. The last time I did this I used my mill like a shaper, which is kind of an annoying workaround and it takes forever. So this time I bought the proper tool, which is a keyway broach. It's a cutting tool that slides into that guide I just put in there, and then you press it through the hole using an arbor press, or in this case a hydraulic press. And each of these teeth cuts a little bit deeper than the last one, and when it's all the way through you end up with a nice, accurate, clean keyway, and it only takes a few minutes. Now it just gets a thread for a set screw to hold this in place on the shaft, and then it's ready to install. Next I'll make these two pins. They are made from stainless just because I had some round stock with the right diameter, so I only need to drill and tap these on one side and then they're done. And now for these sleeve parts. I think I made these from C45 as well. Now I'm just milling some flat spots so that I can grab these with a wrench to install them. I'm going back to the pins for a second to add one missing feature, and that's a channel which is going to keep these from sliding all the way out of the sleeves. You'll see how that works in a minute. So when that pin is inside, you can put a screw into the sleeve part using some Loctite and set the depth so that it engages in the channel, and then the pin is able to slide back and forth, but the screw keeps it from sliding all the way out, which would be kind of annoying when you're using the clutch. Next up is the base plate that goes onto the motor. The motor uses 3 mounting screws, but I'm drilling 6 holes here just in case I need to install it in a different orientation for some reason, so I have a few different mounting options. Okay, we're able to install all the main parts now to see if this actually works as intended. Of course I'm putting some grease into these holes so that this slides easily. As I expected, there was a small problem here. The grease closed up all the gaps, so there's no vacuum inside, and you get a suction effect, which is kind of annoying. But that was easy to fix by just drilling a small hole into the back, so now the air can escape. The two holes that I'm putting the screws in here were drilled oversized on purpose, and that gives it a little bit of wiggle room so I can align all these parts, because the pins need to be centered in those sleeves, otherwise the whole thing tends to bind up. And I had to play around with this for a bit, but eventually it went in and out pretty smooth. There's a few minor things left to do. I'm making some chip guards from sheet metal. One of these installs onto the motor assembly and the other one to the table, so they overlap. And while I was at it, I also made this little knob to hold on to, so you don't have to grab the motor to operate the mechanism. The last step is to set up the electrical stuff. I bought this aluminum case here, which happened to be the perfect size for a control box. As you can see, it's a pretty tight fit, and fitting everything in there took a bit of thinking, because I'm also going to add and replace some of the switches. The power supply came with this handy connector, and I also put these crimped connectors on all the cables, just so that assembling and disassembling this whole thing is a little bit easier. Hooking this up is generally pretty easy. You just put the power input and output wires onto these terminals, and that's pretty much it. This display is kind of weird because it offers absolutely no way to attach it to anything, so I have no idea how you're supposed to actually install it. But my solution was to mill out this little bracket here that has an opening slightly smaller than the display housing, so that I can kind of squeeze it in there and hold it by just using friction. Now I just need to mill a window for that and some holes for the switches. I also want a rapid or a turbo button to quickly move the table, and that's what this button is for. And for the direction, I'm obviously not using the cheapo plastic switch that came with the controller, so that gets replaced with this metal switch. Implementing the turbo button was actually easier than I thought. At first I was going to bypass the entire controller, but then I ended up just connecting these two wires from the potentiometer to the button. And now when you press it, it simply bypasses the signal from the potentiometer, which basically sends the controller the same signal that you would get by turning the dial all the way up. So now as long as you keep the button pressed, it always goes to 100, or I guess 99%, and otherwise it uses whatever you set the dial to. Now I just need to install this onto the mill, and this bracket is at an angle on purpose because I'm going to put this on the base of the mill. I don't want this moving around with the table, and by tilting this up a little bit the display is easier to read down there. All the cables can be stuffed under the mill to keep this looking somewhat clean, and with that it's ready to use. Considering what I paid for these parts, I'm pretty happy with how this works. There's a good selection of speeds, the clutch works nicely, and I realized you can even engage it while the motor is running. With the type of speed control I'm using here, the downside is that the torque drops off as the speed gets lower, but I found that even with the slowest feeds it takes considerable effort to stop the table from moving, so it's not a problem even on heavier cuts. And that's it for today. Thanks for watching.